Hi, my dear electrical aspirants. TSSPDCL AE Assistant Engineer exam you wrote yesterday. I hope you wrote very well because, for example, electrical machines తీసుకుంటే almost 11 questions వచ్చాయి సార్. దాంట్లో ఒక 3 to 4 questions dead easy questions, ఒక 4 or 5 questions కొంచెం అనలైటికల్ questions, then after problems 1 or 2 questions difficult. లైక్ అంటే క్వశ్చన్ పేపర్ ప్యాటర్న్ పర్ఫెక్ట్గా ఇచ్చారు జనరల్లీ. ఫైనల్గా ఎలక్ట్రికల్ మెషిన్స్, పవర్ సిస్టమ్స్ కాకుండా మ్యాథ్స్, ఈఎంఎఫ్, సిగ్నల్స్ ఎవరైతే బాగా చేస్తారో వాళ్ళకి జాబ్ వస్తుంది సార్ జనరల్లీ. ఓకే, లెట్స్ సీ ఎలక్ట్రికల్ మెషిన్స్ విషయానికి వస్తే హౌ దే ఆస్క్డ్ క్వశ్చన్స్. లెట్స్ సీ వన్స్ హౌ దే ఆస్క్డ్ క్వశ్చన్స్. ఫర్ ఎగ్జాంపుల్, దిస్ ఇస్ ద క్వశ్చన్ ఫ్రమ్ ట్రాన్స్ఫార్మర్స్. ఏమన్నారు సార్? విచ్ ఆఫ్ ద ఫాలోయింగ్ స్టేట్మెంట్స్ ఆర్ కరెక్ట్? ఏది కరెక్ట్? ద కాన్సెంట్రింగ్ కాయిల్స్ ఆర్ యూజ్డ్ ఫర్ కోర్ టైప్. మనకు తెలుసు, ఫర్ కోర్ టైప్ కాన్సన్ట్రేటెడ్ వైండింగ్, ఫర్ షెల్ టైప్ శాండ్విచ్డ్ వైండింగ్ వీఆర్ యూజింగ్. సో దిస్ ఈస్ 100% correct for core type concentrated, whereas interleaved coils for shell type transformer. Of course, even in core type and shell type we are using interleaved coils. This is correct statement. Next one, the concentric coils used for shell type, is the wrong statement. We know already. Next one, shell type transformers preferable for low power levels. How sir? Generally concentrated winding used for high voltage low current applications, nothing but low power applications, low rating applications. Shell type used for low voltage high current applications, nothing but high power levels. So shell type used for high power, the core type not used for high power. So shell type low power is the wrong statement. Shell type transformers are preferable for high power. Yeah, this is correct statement. So the answer is P and S. The answer is P and S is the correct statement. Very easy question, sir. Let's see the next question. See here. What is the answer for this question? Again from single phase transformers. Very easy question. Let's see. Which of the following statement is not true? Remember that point. Sir, if the load current is kept constant, when the load constant, the maximum efficiency occurs at unity power factor. Yes, when the load constant, maximum efficiency occurs at unity power factor. The next one, the transformer efficiency maximum at the same load current regardless of variations in the power factor. Of course, this is also correct statement. Next one, if the load current is kept constant, maximum efficiency occurs at 0.8 power factor lagging. We already discussed about this already. This is kept constant, maximum efficiency occurs at UPF. So this is wrong statement. What they asked, which is not true, so this is the answer. That's it. What about next one? The core loss and copper loss of a transformers are unaffected by a variation of power factor. Of course, at any power factor, the losses are constant, of course, regardless. Especially that 0.8 lagging, 0.8 leading, even efficiency also same. Generally, previously, like a questions they asked in previous examinations. Of course, in this is 100% wrong. You can identify easily. So this is the wrong statement. Next one, 28. Next, 29. What is this question? The full load voltage drops in a single phase transformer are 3% and 4% due to resistance and leakage reactance. Nothing but this is simply the percentage resistance or per unit resistance. This is simply percentage reactance or per unit reactance. The full load power factor at which the voltage drop is maximum, the load power factor at which the drop is 0. Nothing but voltage drop maximum, nothing but maximum voltage regulation. Voltage drop 0 means zero voltage regulation. Sir, how we can identify this? Generally, the maximum regulation will be at lagging. Zero regulation will be at leading. That is simple thing. We know that. So maximum regulation will be at lagging, will be at lagging, will be at lagging. This is leading, this is wrong statement. Next one. The zero regulation will be at leading. It will be at leading. It will be not lagging. This is also wrong statement. So B or D, which is correct? Which is correct? Simply the maximum voltage regulation condition. What is the condition? Generally the voltage regulation is equals to per unit R or percentage R into cos pi. Maximum voltage regulation at lagging, minimum regulation at leading, per unit x into sin phi. This is actually voltage regulation formula. To get the maximum voltage regulation, differentiate the voltage regulation with respect to variable. The power factor angle is the variable here, for example. With respect to variable, then derive the equation and equals to 0. If you do that, what you will get? The cos pi is equals to percentage resistance or per unit resistance by percentage resistance or per unit impedance. This is the maximum voltage regulation condition. You can get this one. Percentage resistance or per unit resistance is the 3 upon square root of z. That's why 3 square plus 4 square, which is square, 5 square. So 3 by 5. What is 3 by 5? 0.6. 0.6 lagging is the correct answer. The maximum regulation will be occurs at 0.6 lagging. For example, if you want to get zero voltage regulation, what we have to do? The voltage regulation should be 0. Nothing but this value equals to 0. Then again try to calculate in terms of cos pi. You will get cos pi is equal to per unit x upon per unit z. So 4 upon 5, nothing but 0.8. 0.8 leading is the correct answer. Option B is the correct answer. This is also actually easy question, sir. You need to analyze up to this much. Okay, so this is the next question. In transformer, I think these are the 3 questions. Next, coming to induction machine. This question from induction machine. Let's see this question. 3-phase squirrel cage induction motor has a slip corresponding to maximum torque. Nothing but SMT they given. 20%. 20% nothing but 1 out of 5. 1 by 5. Or 0.2. Its starting current is 5 times the full load current. Starting current is 5 times the full load current. Starting current is equals to 5 times the full load current. Then the full load slip, how much? We need full load slip. Actually, we have one formula. Starting torque to the full load torque is equals to full load slip into starting current to the full load current whole square. Starting current to the full load current whole square. This is the formula generally we will use in the starters. Another formula also we have. Starting torque to the full load torque. Starting torque to the full load torque. Actually, you will remember up to this starting torque to the maximum torque ratio and full load torque to the maximum torque ratio. You know this actually. 2 SMT by 1 plus SMT square. And here 2S into SMT upon S square plus SMT square. You know these formulas. You can derive directly starting torque to the full load torque, maximum torque, cancel. This 2A gets cancelled. Then you will get what will be the answer? This value S square, nothing but full load square plus SMT square. S square plus SMT square upon S into 1 plus SMT square. 1 plus SMT square. Of course, just avoid this one. Compare these two now. What is this? S is the S only. S square plus A square nothing but 1 by 5 square. 1 by 25 upon S into 1 plus 1 by 25. 1 plus 1 by 25 is equals to S into starting torque is equals to 5 times the full load torque, nothing but S into 25. S into 25. Now calculate this. This is 25 into S square 25 into s square plus 1. 25 into s square plus 1. 25 cancelled in the denominator. This is 26 into s is equals to s into 25. Of course, will you bring this? So 25 into s square plus 1 is equals to 26 into 25 into s square. 26 into 25 into s square. So 1 is equals to, take a common of 25 into s square. 25 into s square common. This is the 26 and minus 1. Again 25 will be there. So s square is equals to how much? S square is equals to how much? S square is equals to 1 by 25 into 25. S square is equals to 1 by 25 into 25. So S is equals to 1 by 25. S is equals to 1 by 25. 1 by 25 nothing but 0.04. 0.04 nothing but 4%. It's very easy. Actually, option B is the 4%, sir. It's a 4%. Option B is the 4%. Generally, of course, lengthy, but you need to solve up to this. If you know this formula directly, if you compare them, you will give the answer directly. Okay, you need to calculate this, sir. So this is one of the induction machines question, of course, somewhat lengthy. Next question, the operation of three-phase induction motor. FR represents the air gap MMF. For example, this is my FR, which represents the air gap MMF. F2 represents the rotor MMF. F2 represents the rotor MMF, and T2 represents the angle by which rotor current lags the rotor EMF. Generally the rotor EMF and the air gap MMF are 90 degrees to each other. Nothing but the rotor EMF 90 degrees lagging to this one. 90 degrees lagging to this one. Then after he said that theta 2 represents the angle which rotor current lags the rotor MMF. For example, this is my rotor current. This is my rotor current. This is the angle which is theta 2. This is the angle which is theta 2. The rotor current which produces the rotor flux. The rotor flux which produces the rotor MMF. The rotor flux which produces the rotor MMF. This is the main field MMF. Sorry, air gap MMF. Air gap MMF. This is the rotor MMF, of course. So, pick up the correct answer. Pick up the correct answer. The air gap MMF leads rotor MMF by 90 plus T2S. Yes, this is in leading, and this F2 is in lagging. This is in leading at what angle? 90 plus theta 2. At what angle? 90 plus theta 2. This is leading at 90 plus theta 2. That is 100% correct answer. FR lags F2. FR in leading, not in lagging, sir. FR in leading stage. So option A is the correct answer. This is called analytical questions. Really good question, sir. Next, this is called dead easy question. Dead easy question. What is that? Which of the following single phase induction motor has highest starting torque? Generally, all are the not a self-started motors. Of course, here we can use shaded poles, but this is used for low rating applications like a toys, hair dryers, etc. We don't have a maximum torque here. Highest torque. Permanent capacitor, of course, this is for high power factor, not for high starting torque. Then after resistance split phase, of course we have a, but not compared to capacitor starting. Capacitor starter induction motors are really high starting torque. We know that. Very dead easy question. Next question. This is also dead easy question. A dead easy question actually. Okay. What is the question? In case of three-phase cylindrical rotor synchronous machine, of course this is a synchronous machine. The armature current IA lags the excitation MMF by 90 degrees. For example, this is the main field flux, and this is the, of course, the EMF, of course, the excitation EMF, which is which is 90 degrees, lags 90 degrees. The armature current is 90 degrees in lagging. This is my armature current. This is my armature current. This is my armature current. What is the armature reaction? The armature reaction, this will be the armature flux. Both are in opposite direction. Both are in opposite direction. Nothing but demagnetization. But see the options. Demagnetization in case of synchronous motor. This is not motor, sir. This is alternator. This is alternator. What I written here, this is for alternator. Magnetization in case of alternator. In case of alternator, not magnetized. Cross magnetization never goes when the 90 degrees lagging and the 90 degrees leading. The cross magnetization will be takes place at unity power factor. Magnetization in case of motor, we don't know. Demagnetization in case of alternator. This is correct statement. Demagnetization in case of alternator. Here, demagnetization in case of motor, cross magnetization never happens at 90 degrees. For example, for motor, this is EMF and this is my main field flux for motor. When armature current is 90 degrees in lagging, this is my armature current, this is my armature flux. Both are in the same direction, which is magnetization. Coming to option C, magnetization in case of motor, demagnetization in case of alternator. Of course, this is an easy question. Even without analyze, just you have to remember these points. One of the easiest question. This is also easy question actually. What he said, choose the correctness of assertion and reason statements. Assertion, short circuit characteristics of alternator is a straight line. Of course, short circuit characteristics IA with respect to IF. When IA increases, IF increases linearly. This is a straight line. This is 100% correct answer. Alternator during the short circuit test operates under short circuit saturated condition. Under short circuited condition, the alternator will be operates at 0 power factor lagging. When the alternator at 0 power factor lagging, that is demagnetized condition. There is no possibility of saturation. That is in demagnetized condition. So this is the reason is wrong. The false, true, true, false. So option B is the correct statement. Option B is the correct statement. This is also easiest question only. Next one. Compared to all questions, this is dead easy. Generally, in lap winding, wave winding. Generally, in lap winding, we have a many number of parallel paths. And one parallel path covers only one pair of poles. It leads to change in voltage variations. It leads to more circulating currents. To avoid the circulating currents, we need to reduce the circulating currents. We need equalizer rings. Generally, the wave winding is an incomplete winding. That's why we need dummy coils for mechanical balance. We need dummy coils. So, lap winding needs equalizer rings. Wave winding needs dummy coils. Lap winding, dummy coils needed. Wrong answer. Lap winding, equalizer rings needed. Very nice. In wave winding, dummy coils needed. Very nice. In wave winding, equalizer rings. Wrong answer. So B and C are the correct statement. Correct statement, right? So this is the correct statement. See, on the lap winding, wave winding, they are asked questions. Next question. Next question. When armature reaction is neglected, see the question. Here armature reaction neglected. Don't consider the armature reaction. DC shunt motor speed versus IA and torque versus IA. When the terminal voltage and IF field current constant. Terminal voltage constant, field current constant. Now I am going to draw the armature current with respect to torque. We know torque directly proportional to phi into Ia. When the field current constant, when the voltage constant, the flux constant. So when Ia and torque are in linear, torque and Ia linear. So torque and Ia linear, torque and Ia non-linear kaadu. This is linear. This is correct statement. Next, speed. Of course, the DC shunt motor, The DC shunt motor, this is the no load speed. When the load increases, when the armature current increases, the speed slightly reduces. When the armature reaction neglected, I am not considering the armature reaction. So the curve is like this. This is also linear. There is no parabola, there is no hyperbola, there is no rectangular hyperbola. That is a linear curve. That is also linear curve. This is also linear, this is not non-linear. So A and C is the correct answer. Very well. Easiest question, sir. But in the examination, your mind say something option B, option A, option D. The remaining options are dominating in your mind. You need to control that one. Right? Next. I think this is the last question. In our electrical machines, this is the last question. The tough question. This is the tough question. Of course, previously we done one numerical question. Of course, that is easy. You need to do. But here you need to observe many points. See, the voltage they given 125 volts. DC shunt motor has a armature resistance they given 1/2 ohms. And field resistance they given 125 ohms. Driving load torque constant, the torque constant. Initially the speed is 600 rpm. 600 rpm. Initially the speed is 600 rpm. The motor draws a line current of 11 ampere. Line current of 11 ampere. What is the armature current then? What is the armature current? This is a motor nothing but IL minus ISH. IL is the 11, ISH V by RSH. V by RSH is the 1. So the armature current is 10 ampere. That's it. Armature current is 10 amperes. What is the back EMF? Back EMF V minus IARA. V minus IA is the 10. RA is the 1/2. Nothing but 5. So the EB back EMF is 120 volts. For 120 volts, 600 amperes. For 120 volts, 600 amperes. What is that? The back EMF or the speed directly proportional to EB by 5. EB by 5, of course. Next one, what they given? The new speed of the motor if an additional resistance of 125 inserted. Now the RSH is the 250 ohms. Now the RSH is the 250 ohms. Now the RSH is the 250 ohms. Nothing but, of course, the field current reduces to 1/2. Nothing but the flux reduces to 1/2. The flux halved. When the flux halved, the torque should be same. The flux halved, the torque should be same. What about the armature current? The armature current doubled. The armature current will be doubled. 20 amperes. When the flux halved, the torque should be same. So the armature current will be doubled. So now the armature current is 20. So now the back EMF 125 minus 21/2. 21/2 nothing but 10. Nothing but 115 volts. This is the back EMF. Now N2 by N1 is equals to EB2 by EB1. EB2 is the 115, EB1 is the 120 multiplied with Phi1 by Phi2. Phi1 nothing but take the field current. Phi1 is the first field current is the, of course, let's take the flux phi, and now the flux is phi/2 because the field current halved, so the flux halved. This 2 gets cancelled. This 2 will come here. 0, 120 once, 120 phi, and this phi, this 2, this completely 10. So N2 is equals to 115 multiplied with 10. 115 multiplied with 10. 115 multiplied with 10. So 1150. Of course, you need to remember this point, the torque constant when the flux halved, armature current doubled. Based on that, we need to give the answer. When the resistance increases, field resistance, the flux halved. Based on that, we can get the answer directly. So this is the DC machines. This is the questions on electrical machines. These are the questions on electrical machines. So see, generally in this question paper, actually they asked mixed, like a very easy questions, tough questions, very tough questions. బట్ వట్ ఎవర్ ద క్వశ్చన్, ఏ క్వశ్చన్ చూసినా సరే దిస్ ఈజ్ నాట్ రిపీటెడ్ క్వశ్చన్స్, దిస్ ఈజ్ న్యూలీ అంటే కూర్చొని రాసిన క్వశ్చన్స్. అఫ్కోర్స్ ఈజీ క్వశ్చన్స్ రాసినవే అవి. అంటే ఏ క్వశ్చన్ అయినా సరే మీరు ట్యాకిల్ చేయాలి ఎగ్జామ్లో అంటే ఫస్ట్ ద కాన్సెప్ట్, మీ మైండ్లో కాన్సెప్ట్ ఉండాలి, గుర్తుపెట్టుకోండి. ఇప్పుడు లాస్ట్ చేసిన ప్రాబ్లమ్ని చేయాలంటే కాన్సెప్ట్ రావాలి సార్. ఆ క్వశ్చన్ ఎక్కడ ఉండదు, మీకు ఎక్కడ కనిపించదు సార్. ల్యాప్ వైండింగ్, వేవ్ వైండింగ్ అది ప్రీవియస్ క్వశ్చన్ సార్. అఫ్ కోర్స్ అలాంటి ఈజీ క్వశ్చన్స్ ప్రీవియస్ అయితే ఏమి, ఎలా అయితే ఏమి మీరు ఆన్సర్ చేస్తారు కదా. ఇలాంటి క్వశ్చన్స్ ఆన్సర్ చేసిన వాళ్ళకి జాబ్ వస్తుంది, దట్స్ ఇట్. సో ద థింగ్ ఈజ్ దట్ కాన్సెప్ట్, యూ నీడ్ టు లెర్న్ ద కాన్సెప్ట్. ఓకే అమ్మా, థ్యాంక్ యూ. నెక్స్ట్ వీడియోలో రిమైనింగ్ సబ్జెక్ట్స్తో మళ్ళీ మీ ముందుకు వస్తాం. సో జస్ట్ ప్రిపేర్ వెల్, కీప్ ఆన్ ప్రిపేర్. అండ్ ఇన్ తెలంగాణ వీ హ్యావ్ అసిస్టెంట్ ఎగ్జిక్యూటివ్ ఇంజనీర్ ఎగ్జామ్ నెక్స్ట్ May 8th. అగైన్ Polytechnic lectures exam also is there. Prepare well guys, don't waste your time. This is the correct time. Once ఎగ్జామ్ సెంటర్లోకి వెళ్ళారు అంటే ఈ క్వశ్చన్స్ అన్నింటికీ మీ దగ్గర ఆన్సర్స్ ఉందన్న కాన్ఫిడెన్స్ ఉండాలి. అంటే డోంట్ వేస్ట్ యువర్ టైమ్ నౌ. ఓకే, ప్రిపేర్ వెల్, రైట్. విల్ బి మీట్ విత్ అనదర్ వీడియో, అనదర్ సబ్జెక్ట్, రైట్. థ్యాంక్ యూ.